Alright, this is where we left off in our previous video. Let us try a little thing here. In our previous video we integrated this and we use u for ln x. Now let us use u for x squared and see how things would go. So our u is x squared dx. So our du would be 2x. Now if our u was x squared, then our dv would be ln x. So our dv is ln x. Then to move from dv to v, we would have to integrate ln x, right? And when we integrate ln x, we get x ln x minus x plus c. So we have our x ln x minus x plus c. Now let's just erase some of the work that we did before, and then we're going to work on our, well, not a new problem, it's the same problem but with a different method. We're trying a thing here. What we have is that the integral of u, which is x squared, dv, which is ln x, equal u, which is x squared, times v. Our v is x ln x minus x plus c. So it's x ln x minus x. We're not going to use the constant of integration right now. We're going to leave it off during the work. So minus the integral of v, which is x ln x minus x, times du. du is 2x. Right? We're integrating with x being the variable, so we have dx. So here now, let's see how this would go. What we have is the integral of x ln x dx. I left that off. Equal, this would be x cubed ln x minus x squared by x cubed minus. Let's put a bracket around these things. Alright? Now, by the way, let me write this part properly. The integral of v times du. We're going to find the integral of v du. Now, let me just rewrite this part. The integral, this is the integral of, we're going to open the brackets. So it's going to be 2x squared ln x minus 2x times x is 2x squared dx. Alright? Oh, integral of 2x squared dx. Okay. Now, oh, there's a square here. I left off this square here. Alright. This part now says x cubed ln x minus x cubed minus, open the bracket, the integral of 2x squared ln x. This is now plus the integral of 2x squared. And there's a dx at each because x is the variable. So we have x cubed ln x minus x cubed. You see that? But the thing is now, you have a minus 2x squared ln x. So let's put the minus 2 outside the integral sign. This is the integral of x squared ln x dx. See that? Plus 2 outside this integral sign, integral of x squared dx. Now on the left, what do we have? The integral of x squared ln x dx. Now here, we have integral of x squared ln x dx. We have minus 2 integral of x squared ln x dx. What we want to do is add 2 integral of x squared ln x dx to both sides. When we do this, on the left we have the integral of x squared ln x dx plus 2 more integral of x squared ln x dx will give us 3 integral of x squared ln x dx. You following? Make sure you're following, you know. This is equal to x cubed ln x minus x cubed minus 2 integral of x squared ln x dx plus 2 integral of x squared ln x dx will make this disappear. Alright? Plus now. So we have 2 integral of x squared dx. Alright? So this is equal to x cubed ln x minus x cubed plus 2 times the integral of x squared is going to be x cubed over 3 plus c, right? Then we divide everything. Alright, let's use a different letter for the constant. Let's call it plus k for now. Divide everything by 3. What we have is the integral of x squared ln x dx equals. Now, this would be x cubed ln x over 3 minus x cubed over 3 plus. And then you have 2 over 9 x cubed plus k over 3. See that? We divided everything by 3. Remember, k is a constant, so k over 3 is another constant. All we need to do is change the letter, right? So what we have here, x cubed ln x over 3. Now, we have negative 1/3 plus 2/9. Negative 1/3 x cubed plus 2/9 x cubed. What is negative 1/3 plus 2/9? Well, negative 1/3. If we multiply both top and bottom by 3, we're going to get 3, 1, 3 up top, 3, 3 is 9 down the bottom, in order to use common denominators, right? Now, negative 3 plus 2 is what? Negative 3 plus 2 is negative 1. So it's negative 1/9. So what we have is minus 1/9 x cubed, which is x cubed over 9. See that? Plus, this is our constant of integration. It's k over 3. Let's call it c now. Plus c. I'll just erase this. This was fractions working out. The question is it the same as what we did before? Let's see. We have x cubed ln x over 3. X cubed ln x over 3 minus x cubed over 9 plus c minus x cubed over 9 plus c. Right. So how we did it before, where we use u for ln x and dv for x, it was done with a lot less work and more quickly. It does work when you use u for x squared and dv for, it does work in this method where you use u for x squared, substitute u for x squared and dv for x. It's just that you have a lot more work to do and it takes a longer time, a lot more effort to work it out. But both of them come to the same conclusion, same solution. Alright, so I'll see you in the next video.